A geometric sequence is a sequence where the nth term is determined by multiplying the term before it, or a sub n minus 1, by the common ratio of r. To determine the actual values of each of the terms, you must be given at least one of the terms. For example, the sequence a sub n, where a sub n equals a sub n minus 1 times 4, which has a common ratio of 4, and a1 is 3. The sequence is 3, 12, 48, 192, and you keep proceeding like this all the way up until you get to a sub n minus 1 times 4. This sequence can be found by starting with a sub 1, which we know is equal to 3, and multiplying it by 4 to get a sub 2. Then you multiply a sub 2 by 4 to get a sub 3, and you keep going in this manner up to a sub n. The sequence a sub n can also be written as a sub n equals 3 times 4 to the n minus 1. If you use this formula instead, you end up with the same values. A geometric sequence can be written out as a times r squared, all the way up to a times r to the n, where a is the initial term, or a sub 1. Summations of geometric sequences. A geometric sequence is the summation of a geometric sequence is found by adding together the terms of a geometric sequence up to a certain term. This is written as the summation from j equals 0 to n of a times r to the jth power, which is equivalent to a plus a times r plus a times r squared, and you continue like this all the way up to a times r to the n. Now there's a formula to find the value for this, and that is given by a times r to the n plus 1 minus a, and that quantity divided by r minus 1.
Okay, in order to prove the summation rule for geometric sequences, what we do is we start with S, which we'll set as sum from 0 to n of just a geometric sequence. And what we do is we multiply the entire thing by r, which we could just distribute in. So what we get is this. And this is not really a standard form, so what we do is we set another variable k equal to j plus 1, and this entire thing is now equal to k to n plus 1 of a times r to the k. So what we have right now is this, and this can be rewritten as, like if you expand it, you get this plus 1, and our original formula S was plus r to the n. And you'll notice that the difference between these two equations is this r here, or this a here, and this last term here. So rs equals r, or s plus a to the n plus 1 minus a. So what we have now is this. And if you just do some algebra, solve for s, you get this, which is the summation formula for geometric sequences.
An infinite series is the sum of infinitely many numbers. An example of an infinite series is the sum from I equals 1 to infinity of 1 over 2 to the power of I, whose terms can be written as a, the first term, plus a, the first term again, times the common ratio, plus a, the first term again, times the common ratio squared, plus a times the common ratio to the power of 3, and so on, which in our case is 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16, and so on. The formula for the sum of an infinite geometric series is a over 1 minus r, where a is the first term and r is the common ratio. Applying the formula to our example, we have a equals half, r equals half, so we have half, which is a, divided by 1 minus r, which is half, which gives us 1, which is correct. 1 is the sum of our infinite series.